Hello everyone, my name is Megdusan Akash. I am a student from Brac University and my topic is example and architecture of sequence to sequence using RNN. First, I would like to say thanks to my teacher, Moin Mustakim sir, for allowing me to talk on this topic. These are the content that I'll cover throughout my presentation. First, what is RNN? Secondly, RNN architecture. After that, types of RNN, application of RNN, use cases of the sequence to sequence model, how the sequence to sequence model works, and I'll give a conclusion. First of all, what is RNN? We know RNN is an updated version of a neural network which works for a sequence approval. They have a mechanism of remembering the previous input and producing an output based on all the inputs. This makes them well suited for sequential type of data such as text, audio, video, or any time series data. Recurrent models are valuable in their ability to sequence vectors, which opens up the API to performing more complicated tasks. Here is an example of a RNN. You can see a chef choosing what to prepare in the next day in a sequence order. If first day he chose cake, second day he chose burger, third day he chose chicken, and fourth day he chose cake again. You can see there are some matrix representation here. Uh, in terms of RNN, we get this matrix value and can predict the future. We know there are four types of RNN architecture, such as vector to sequence, sequence to vector. Here is an example of vector to sequence and sequence to vector. There are two more architecture, which are sequence to vector to sequence and sequence to sequence. We'll talk about sequence to sequence as our topic is sequence to sequence. There are four types of RNN: one-to-one, one-to-many, many-to-one, and many-to-many. First of all, one-to-one is a single input that predicts a single output forms, and we call it one-to-one architecture. It deals with fixed size of input to the fixed size of output. One-to-one is essentially a neural network. Then one-to-many, it is a single input that results multiple output values or an output sentence. Is called a one-to-many architecture. It deals with fixed size of information as input and gives a sequence of data as output. The example of one-to-many is a image through caption sentence. After that, many-to-one. It multiple inputs but only one output value is called many-to-one architecture. It takes a sequential of information as input and fixed as of output. An example of many-to-one is a sentence to sentiment. After that, many-to-many. It is a multiple inputs which results in multiple outputs. We can call it a many-to-one architecture. It takes sequence data as input and process the recurrently output as a sequential data. The example of many-to-many is a conversion of sentence in English to a sentence in Turkish. Here are some applications of sequential RNN, such as speech recognition, machine language translation, image captioning, text summarization, question answering, creating chatbots, and video captioning. Machine language translation, text summarization, and chatbot, all these are following sequential model. In terms of machine language translation, you can see a foreign language is translating to English language. In text summarization, we can get the summary of the text, and in chatbot, we are saying that we are getting the reply from the text. Here are use cases of the sequence to sequence model. In Google Translate, if we write something in English, it will convert to French or any other language that we want to convert. So it follows sequence to sequence model. On the other hand, speech recognition is another tool that responds to the sounds produced in human speech. So it also follows the sequence to sequence model. So now, how the sequence to sequence model works? In the following figure, this model consists of three parts: encoder, encoder vector, and decoder. Encoder is a stack of several recurrent units where each accepts a single element of the input sequence. It collects information for that element and propagates it forward. In question answering problem, the input sequence is a collection of all words from the question. Each word is represented as xi, where I is the order of that word. Here, by using this formula, we can calculate the hidden states. This simple formula represents the result of an ordinary recurrent neural network. Encoder vector. This is the final hidden state produced from the encoder part of the model. It is calculated using the formula above. Um, this vector aims to uh, encapsulate the information for all input elements in order to help the decoder to make it more accurate prediction. It acts as the initial hidden stage of the decoder part of the model. Finally, decoder is a stack of several recurrent units where each prediction and output at a time state t. Each recurrent unit accepts a hidden state from the previous unit and produces an output as well as its own hidden state. In the question answering problem, the output sentence is a collection of all words from the answer. Each word is represented as yi, where I is the order of that word. Any hidden state can be completed by using this formula, the first formula. Um, we are using this previous hidden state to compute the next one. The output at time step t is computed using the formula below, the softmax one. We can calculate the output using the hidden state at the current time step together with the respective weight. Softmax is basically used to create a probability vector which will help us to determine the final output. The power of this model lies in the fact that it can map sequences of different lengths to each other. As you can see, the inputs and outputs are not correlated and their lengths can be differ. This opens a whole new range of problems which now can be solved using such architecture. Therefore, RNN is widely used nowadays. Thank you everyone.